So today we'll finish up with conic sections. Okay, we did the parabola before break. That was on the last test. Ellipses we did yesterday, and we'll finish with hyperbolas. Ellipses and hyperbolas are very, very similar, okay, as I said before. So I want to show you the definition for an ellipse, and then we'll compare that to the definition of a hyperbola. Okay, so if you were here yesterday, that's the first thing you wrote down in the notes. But an ellipse is a collection of points in the plane, meaning it's a two-dimensional shape, such that all those points, if you measure the distance from that point to each focus, it adds up to a constant. All right, so if you have an ellipse, and you have your two foci, and you can pick a point anywhere you want on the perimeter, and you measure the distance to the first focus, measure the distance to the second focus, and add up those two distances, it'll always come out the same. No matter where you drag that blue point, the distance to each of those two foci, the sum is always the same. Okay, and that's the key word that makes it an ellipse. If you find the sum of the distances to the two foci, you get a constant. Well, with a hyperbola, the only thing that changes is we change the word sum to difference. So you're still measuring the distance to two fixed points, but now you're not adding them. You're going to take the distances from a point to each foci and subtract them. And you will always get a constant. The number that you get when you subtract them, that can change. It depends on the equation for the hyperbola. Okay, in the specific one I'm going to show you in a second, the difference is always going to come out to 5.66. That's just the particular equation that I have. Okay, so the word that I underlined in blue, that's the only word that changes in the definition of an ellipse versus a hyperbola. And we'll kind of see that theme for those that were here yesterday throughout the formulas. You're going to see you change one thing in the formulas from yesterday, and it's what we're doing today. All right, so let's look at a picture and kind of put that word, put all those words together and help it make it a little more sense looking at the picture. So the two fixed points, okay, that I'm talking about here, the two fixed points in this picture, they're point C and B. Those are the fixed points. Point E is a point that I can drag wherever I want on either part of the hyperbola. And they're not really called parts. They have a name, and I'll tell you that in a second. All right, so as I drag point E, you can watch what's happening. The program will remeasure the distance from E to C, and it'll remeasure the distance from E to B. It's going to take those two numbers and subtract them. And it's always going to take the absolute value. Right? So no matter where I drag this point, and you can, well, I don't want to do that. I need to highlight just the point, not the segment. Might have to do it from the computer. Let's see. Nope, I got it. All right. And if I go over to the other branch, same thing. Okay, and you can double check it. If you take those two numbers and subtract them, okay, you will get 5.66. Sometimes because of rounding, like 9 and 3, that does give you a 6. It's a little bit off. But the point is the difference of those two distances is always the same. Okay. So any questions on the definition of a hyperbola? Okay. So the two fixed points in my picture that were labeled C and B. If you were here yesterday, you probably have an idea what those are called. Anybody know the name of those 2 points? Yeah? The what? Okay. Yeah, they're the foci. Yep. So that's just the plural of focus. And notice the two parts of the hyperbola, they wrap around each focus. Okay? So it kind of wraps around the focus. Okay, if you draw a line that goes through the foci. And I'll draw a picture right here. Say these are your foci. If you draw a line right through it, like that, that line that I just drew is called the transverse axis. And there's going to be names for two axes here. One of them is transverse. And the way that I remember this one is the transverse is, to me, I look at the word transverse and it looks kind of like the word traverse. And traverse means to go across something. Right? If you traverse the bridge or something, it means to go across it. So this is the axis that goes across the hyperbola. It connects the two parts. Right? Transverse. Okay. Yesterday, we would have called that the major axis, okay, in an ellipse. Okay, but today it's the transverse axis. Okay. If you take the 2 points that I just had here, we'll call that F1 and F2. Draw a segment between F1 and F2 and find the midpoint of it. The midpoint is the center. And that's exactly the same definition that we used for the center when we had an ellipse. Except I wrote the midpoint of the segment connecting the foci is the center of the ellipse. Okay? But it's the same thing for hyperbola. Okay, the other axis, okay, yesterday we called it the minor axis. And it has the exact same definition as a minor axis, except in a hyperbola we give it a different name. Okay, the conjugate axis is when you take a line through the center, perpendicular to the major axis. So that line I just drew in green, that would be the conjugate axis. And I said to you earlier that hyperbolas are in two parts. It's the only conic section that, to draw it, you have to pick up your pencil to draw the other part. Okay, and the two parts are called branches. And for a hyperbola, there's two ways you can draw it. This is one way. That's where your transverse axis is horizontal. Or this way. That's where your transverse axis is vertical. Okay, so kind of like an ellipse in the sense there's only two ways to draw it. Technically, you can also draw a hyperbola on a 45-degree angle, and we've done that before. If you look at this picture, I don't think I ever called it a hyperbola. But technically, that is a hyperbola. It's on a 45-degree angle. Right? And if you look at that picture, what did we talk about with this kind of graph? This graph has a certain feature that comes up, and usually we describe it. It has asymptotes, right? Any graph of a hyperbola has asymptotes, and so do the ones we're going to study today. These asymptotes are usually perfectly vertical and perfectly horizontal. If you draw parabolas like this, your asymptotes are not horizontal and vertical, they're more on a slant. Okay? And there's two of them. And we'll talk about how we find those asymptotes. All right, and the last term that we really mention with hyperbolas is what's called the vertices. Okay? The vertices are where the transverse axis cross the hyperbola. So that's your transverse axis. That's a vertex. That's a vertex. Okay? If it went this way, that's a vertex. That's a vertex. So generally, those are 2 points you always want to find when you're sketching a hyperbola. Where are your vertices? Then as far as getting the curvature right, like how wide, should it be a branch that's like that? Or should it be a wider branch like that? That's where the asymptotes come in. The asymptotes are going to create an X shape, and all you have to do is stay inside the dotted lines, and that's your branch. Okay? So that's basically how we'll sketch hyperbolas. Little different than how we sketched ellipses. Because did ellipses have asymptotes? No, ellipses don't have asymptotes. All right, so we got the definition. We've got the picture, which we can kind of explore the definition with a little bit. Now we'll look at the equation. The first equation that I always give you is the basic one, where the center is at the origin. Now, some of the facts that I give you, I'm going to give it to you the way the book does, but I have an easier way to remember it, and that's what I keep on the whiteboard. Okay? If you can remember these 2 facts about A and C, it'll help you to automatically know that, and that. Okay? So those 3 things that I checked off in red, I don't remember them that way. But if it helps, you can write them down. It is correct. But if you're not going to write them down, all I would take away from it is that the foci has something to do with C. The vertices have something to do with A. Whether it's the x-coordinate or the y-coordinate, in this case it's the x, that's easy to figure out just using a little common sense. All right, so there's the equation of a hyperbola. For those that were here yesterday, how is that different from an ellipse? There's only one thing different. Yep. Yes, there's a subtraction sign between the fractions instead of addition. And this is the relationship between A, B, and C. Can somebody tell me how that is different from what we had yesterday? Yeah, this is addition instead of subtraction. Yesterday it was a squared minus b squared. Now, if you look in your packet, they are not going to write this. Okay, the way they write it in the packet is this. B squared equals c squared minus a squared. Is that the same thing? Yeah. All they did was take a squared and move it to the other side. I like to do it the way I did in black, because then the 2 versions of the formula are similar for an ellipse and a hyperbola. One's a plus, one's a minus. To me, if you write it the way in red, it looks like it's something different, because it's arranged for a different letter. Plus, we're used to arranging it for C anyway when we do Pythagorean theorem, even though this is not, it's not Pythagorean theorem. All right, so we got that. And the asymptotes. The asymptotes are going to be on a slant. And if you don't shift it, the asymptotes go right through the origin. That's why there's no y-intercept here. This equation is going to be right through the origin. And the slope of the asymptotes is positive b over ax, or just positive b over a, and negative b over a. Those are your 2 slopes. So in other words, the slopes are opposites. All right, so any questions on anything I have here? All right, the next thing, graphing hyperbola, don't worry about that. Because if we graph the asymptotes, we don't need to do that. You can do that, but we're not going to. And this is the important thing. So A is always the distance from the center to the vertex. C is always the distance from the center to the focus. And once you watch the video on ellipses, if you weren't here, you'll see exactly the same thing written in that video. A is the distance from center to vertex. C is center to focus. And on the whiteboard on the left, that's how I abbreviate it, the way I wrote it in green. Yeah, I'm not sure why they put absolute values around the A in the book, because you don't ever have to worry about A being negative anyway. So I wouldn't be too caught up with the fact there's absolute values around the A. All right, now I want to scroll back up and look at the equation for a second. For those that were here yesterday, how could you tell which way the major axis went? What's the key that told you that? Yep?
Which, underneath X or Y, which number was bigger?
The bigger number. All right, so if you weren't here yesterday, there's not going to be any confusion with this unless you already watched the video. But yesterday, it was the bigger number that told you the direction of the major axis. That's not how it's going to work today. Okay? It's going to have to do with which letter is positive in the numerator. Is it the x that's positive, or is it the y that's positive? If it's the x that's positive, like it is in this case, the positive x value tells us the transverse axis goes in the x direction. If I switch the x and the y, then the y would become positive. If the y is the positive, like in this equation, the y is now the positive, that changes the transverse axis to be vertical. Okay? So I'm going to come back to this when we get to it. I just wanted to quickly show you the difference between transverse axis being horizontal and being vertical. It all has to do with which letter is the positive one. Okay. Another thing, yesterday, Josh, could A and B switch places yesterday?
Yes.
Yes, A and B could definitely switch places. Today they don't. A is always going to be your first denominator. B is always your second. That never changes for every single problem. Okay. A is always the first denominator. B is always the second. Always. What does switch is the numerators. Okay. So a little bit different than how it worked yesterday, but I think if you understand how to do hyperbolas, the ellipses won't be too bad after. Okay, so let's find the equation of this hyperbola, and we'll graph this one. I don't want to spend a ton of time graphing every problem, but we'll just graph this one. Okay, so the first thing you have to do to find the equation is to find A, B, and C. All right, so we know the definition of A is the distance from the center to the vertex, and C is the distance from the center to the focus. I have enough information to find all of that. So what would A be here? 2. Yeah, we're always going to write it as a positive. Maybe that's why they put absolute values around it, in case you wrote it as a negative. But we'll always do it as a positive. So A is 2. And then C, what's the distance from the center to the focus? 3. Now, the problem is to write the equation, you have to have B. But what's the formula here that relates A, B, and C? Yeah? C squared equals A squared plus B squared, and fill in for C squared. So we get 9. We get 5 equals B squared. So that means B equals square root of 5. You're not really going to need the square root of 5, because when you plug into the formula, the denominator is B squared. You're going to need that anyway. But if you just want to write it, you can. All right, so we can set up our equation. So we got a fraction, Okay, equation for hyperbolas and ellipses, always equal to what number? 1. What sign goes between the fractions? A subtraction. Okay, for hyperbolas, it's a subtraction. My first denominator is always, what did I say it always is? A squared. Second denominator? B squared. And now we just have to figure out, is it xy or yx squared? Okay. If you're not sure, graph these points and see how they line up. The transverse axis is going to go right through all those points. So we've got 0, 0. I'm just estimating. 3, 0. Negative 2, 0. Which way does my transverse axis go? It goes horizontal. So if I want it to go horizontal, horizontal is which axis? The x-axis. So that means I want that one positive. So make the x positive, make the y the negative, and there's your equation. And if all you need is the equation, you don't have to find the asymptotes. If you're going to graph it, then you do. Okay, so let's find the asymptotes. And what's the slope of my asymptotes? Is it b over a, or is it a over b? When the transverse axis is horizontal, it's b over a. And I haven't gotten to this one yet, but it's easier to remember. When the transverse axis is vertical, the slope is a over b. So if you remember VAB, VAB, vertical, a over b. And then, well, the other one is Chabad. I don't think that really helps. But if it does, great. Okay, so this is horizontal, slope is b over a. B is the square root of 5, which if I'm going to graph it, I really need a decimal so I can do my rise over run. So that's about 2.2 over 2. Okay, again, only reason I wrote it as 2.2 is so I can go my rise over run. So I've already graphed both those lines, starting at the origin, up 2.2 over 2, up 2.2 over 2. And same thing here, down 2.2 over 2, down 2.2 over 2. So those dotted lines give me kind of boundaries where my hyperbola is going to be. The only thing I want to graph now are the vertices. That tells me if it's going to start close to the origin or does it start further out. What letter tells you the vertices again? Yep. A. And we already have one of them. Negative 2, 0. And if the vertices are symmetrically placed around the center, where's the other vertex? 2, 0. So now just draw your branches and try to keep them close to the dotted lines. So get something kind of like that. And let's see through my shadow, like that. Just try to get closer. Okay, and there's your hyperbola. Okay. Any questions on that? Okay, where would the foci be if they asked me for the coordinates? Because I think, did they give me both of them? No, they didn't give me both of them. I got one at 3, 0. Where would the other focus be? Yeah, it would be negative 3, 0. So the focus is not actually a point on the hyperbola. It's something it wraps around. So that's a focus. That's a focus. So, technically, you do not have to sketch the foci when you're sketching the hyperbola. It's not part of it. Okay, any questions on that one? Okay, let's try this one. This time, I'm giving you the equation, and I wanted you to describe the vertices, the center, the foci, which way the transverse axis goes, and the asymptotes. Okay, first of all, is that equal to the number that it should be? Yes, it's equal to 1, so it's ready to discuss. Okay. We have to identify A, B, and C first. Looking at a hyperbola, how do you identify where A is? It's always the first denominator. Well, actually, it's A squared. But the first denominator is A squared. So what's A? And B? 2. And now C, we're just going to do C squared equals A squared plus B squared. So what would C be? Square root of 20. All right. First thing you want to always identify is your center and the transverse axis. So I didn't really write these in the order you do them, but let's always do this one first and that one second. So if you want to put them in that order on your paper, that might be better. After you get those two, you can do anything you want. Where do you think the center is here? Yeah.
Because there's nothing added or subtracted to the x and y, it would be an origin.
Yeah, until you start adding and subtracting things to x and y, you haven't shifted it. So the center is 0, 0. And which way does the transverse axis go? Horizontal? How do you know that? It's the one that's positive. So if you were here yesterday, you might say, oh, it's where the bigger number is. We forget about that idea from yesterday. That was only for an ellipse. Okay? It's the one that's positive. So transverse axis is horizontal. What that tells me is that everything is going to be to the left and to the right of the center. It's going to line up horizontal. If the transverse axis is vertical, I would be figuring out things above and below. Okay? But I'm left and right. The vertices are how many units from the center? Josh? 4 units. A always tells you how far the vertices are from the center. So I need 4 units horizontally from the center. So what would be the 2 coordinates that are 4 units away from the center horizontally? Can you say them again?
4 is -4, 0.
Yeah.
And then
Positive 4, 0. Yep. So those are your vertices. And now the foci, what letter tells me the distance that the foci are from the center? C. It's going to be the same idea. They're square root 20 units to the left of the center and square root 20 units to the right. It's about 4 point something units. Okay, asymptotes. When I'm horizontal, what's my slope again? B over A. So my asymptotes are going to be y equals, scroll up, 2 over 4. What's 2 over 4? 1/2. Positive and negative. So those are the 5 things you'd have to write down when you describe a hyperbola. Okay. Any questions on how we found any of those 5 things? Might not ask you for all 5 on the test. Okay. If I give you an equation, I might just say, what are the asymptotes and what are the vertices? Okay. But that's everything you could possibly describe. All right, let's discuss this one. Okay. What's going on here? It's not equal to 1. If it's not equal to 1, you need to stop right away and get it equal to 1 before we do anything else. How would you do that? Divide everything by 36. And now 9 goes into 36 how many times? 4. And then, well, 4 goes into 36. 9. And there's your hyperbola. Hey, just a quick check from yesterday. How do you know it's not an ellipse? Because there's a subtraction sign. Okay, there's not really problems on the test where I say, what is this? But in general, if you take a class, you could be given problems like this, and you might have to figure out what shape it is first, and then work with it. Okay, on mine, it's pretty much organized on the test by shape. Okay, so you won't have to figure that out. What's A here? Yep. Square root of the first denominator. B? 3. And then C, it's basically like doing the Pythagorean theorem. Square root of 13. All right, so did I already write down? Yep. Okay, let's do the center first. Where's my center? The origin. Transverse axis goes which way? Horizontal again, because x is positive. How many units away from the center are the vertices? 2 units horizontally away from it. So what would be the coordinates? Foci? How many units away from the center are they? Square root of 13, left and right. So negative root 13, positive root 13. And there's nothing you could do with the root 13. In the last problem, I think we had a root that you could simplify. Yes, you could write that as 2 root 5. Okay, so if they simplify that on the test, make sure you look for that. And the asymptotes. Yeah, b over a, which is 3/2. Okay, so that would be a nice one if you had to graph the asymptotes. It wouldn't be too bad. If you have to graph the vertices, that wouldn't be too bad either. You have nicer numbers to work with. Hey, any question on finding those 5 things? Okay. So now we'll switch it to the case where the transverse axis is going to be vertical. How can you tell, just by looking at the equation and based on what I've explained so far, that the transverse axis is vertical here? Now the y is the positive letter. The transverse axis always goes with the positive letter. Everything else is the same. C squared is still equal to a squared plus b squared. The foci has something to do with C. The vertices have something to do with A. But now, instead of being to the left and the right of the center, everything is going to be above and below the center. So you're going to be changing your y coordinate now, not your x. And I think I already told you this, but what do you think the slope of the asymptotes is going to be? Now it's going to be a over b. Okay, in this one, I think it's easier to remember if I gave you that hint, VAB. If it's vertical, transverse axis is vertical, the slope is a over b. Okay, so when I'm doing this kind of problem, all I remember is the hint for the slope and the fact that A is center to vertex, C is center to focus, and I can figure out everything there. Okay, so we'll try an example with this, and then we'll do the case where we shift it. So then the center is no longer at the origin. For that, what I did is I just photocopied the chart that's in here, and I'll tell you the page it's on, and I put that in the smartboard. So it's a lot of stuff to copy in the chart, so I'm not going to leave it up long enough to copy because you have it in your packet. Okay, so I want to discuss this shape, which is a hyperbola. What would I do first? Yep, we're going to divide everything by 4. So that's going to be y squared over 4 minus x squared. What could we put for a denominator? We need something. Yeah, just keep a 1 there. Equals 1. So step 1, get your equation in the right form. Step 2, identify A, B, and C. Okay, what's A? 2. B? Square root of 1, which is 1. And C? Square root of 5. Any questions on A, B, and C? And now we just do it just like we did the last 2 problems. Same thing. What should I find first? Center, because everything is based off the center, either above and below or left and right. We'll answer that question in a second. What's my center? Still 0, 0. Transverse axis, vertical, because y is positive. So now the vertices are how many units from the center? 2. Above and below or left and right? Above and below. What would be 2 units above the center? Yep, 0, 2, and below. Foci, same idea. It's square root of 5 units away from the center, above and below. So 0, square root 5. You could technically write 0 plus or minus square root 5. That doesn't work all the time if it's shifted. But if it's not shifted, everything is symmetrical, okay, around the origin. So asymptotes. What would be my asymptotes here? 2. Positive or negative 2x. Again, not a bad one to graph if you had to graph the asymptotes, because you have a nice slope to work with. Okay, questions on that one? All right, so we haven't tried one like this in a little bit. I'm giving you some information. You tell me the equation of the hyperbola. Okay, what's the first step to find the equation of a hyperbola? You got to get the A, B, and C. With the information they've given me, is there anything there that I can find? Yes, I can find A. What's A? 2. Okay, and I have to be able to find something else. Yep, C is 3. And there's actually another piece of information I can infer from what they've given me. I don't need it right now. But does anybody see what else must be true that they didn't say? Yeah?
The transverse axis has to be vertical.
Okay, the transverse axis will be vertical. Something else. Okay, it's not shifted. We know that because the center is 0, 0. But there's one more thing that I can automatically tell here because of symmetry. True, I know it's not an ellipse because when you have an ellipse versus a hyperbola, you have 4 points. You have 2 vertices and 2 foci. For one of the shapes, the foci are outside. For the other shape, the foci are on the points on the inside. They actually switch places in an ellipse and a hyperbola. If you sketch it, you'll see that. But the other thing is, I know there's another vertex at 0, negative 2. They didn't tell me that, but because of symmetry, there has to be. That's what I was thinking of. All right. So let's set up our equation. Sign between the fractions. Subtraction and equals 1. Okay. Oh, I can't do my second denominator yet, but my first denominator I can do. 4. And my second denominator, we never figured it out. 9 equals 4 plus b squared. Square root of 5. So, second denominator is 5. Okay. If you're not sure which letter should be positive, graph those points. Okay. 0 down 3, 0 up 3, 0 up 2. Everything's lining up vertical. So which letter should be positive? Y. X is negative. There's your equation. That's it. And for those that were here yesterday, or even if you weren't actually, could you graph that on the calculator? Yeah. What letter would you have to get by itself? You'd have to get y by itself. So you'd have to add the x squared over 5, push that to the other side, then multiply by 4 to push that over, and then you'd have to take the square root. So it'd be a little messy, but the calculator could graph it, and it would graph it in two parts. It would graph like the top part and then the bottom part separate. Good. Any questions on that? All right. Does anybody feel like we need to do another discuss one of the ones that aren't shifted? We've done a few of them. All right. So that's the chart from your book. Okay. Most of this stuff, I don't even think about that really. Because if I know the foci are C units away from the center and the vertices are A units away from the center, I can just figure that out. To me, that's just more stuff to try to memorize that I don't need. This, I don't memorize either. I told you this is how the book writes it. I think of it as Pythagorean theorem. That's how I remember it. C squared equals A squared plus B squared. Okay, so you don't really need to think about that. The equations you need to know. Okay, so the two equations are important. So the top one is where your transverse axis goes in the horizontal direction. The bottom one is where your transverse axis goes in the vertical. And that's because the y is positive. The two new letters that we're going to be using are HK. That's important. HK is going to be the center. Okay? HK is always the center. So now when we find the equation of ellipse, you're going to have HK, ABC, 5 letters. Here's also a good picture to illustrate what I was talking about. In a hyperbola, the foci are on the outside and the vertices are on the inside. In an ellipse, that's switched. The vertices are the points that are furthest out and the foci are on the inside. What else? Asymptotes. Does this look like anything? This is actually something you did in Algebra 1. It's not y equals mx plus b. Anybody recognize what form that is? Point slope. People remember point slope? Y minus y1 equals m times x minus x1. A little bit? Yeah. That's just the point slope form of a line. Y minus y1 equals m times x minus x1. That's how you studied it in Algebra 1. Okay, so it looks like kind of a lot of stuff, but it's really, we'll go through one. It's not too bad. Okay, and that's all on page, in your packet. What page? 407? Yeah. It's all on page 407 in your packet, kind of towards the bottom. Okay, so let's find the equation of that hyperbola. Okay. Is there anything I can find here with almost no work at all? Don't really have to do any calculations. These numbers are pretty much given to me. Yep. Yeah, H and K are given. What's H? 1 and K? -2. And now A and C, we're going to do exactly the same thing we've done before. Okay. A is the distance from center to vertex. Well, the center and the vertex have the same y coordinates. It means they're at the same height. So all you have to do is look at the difference horizontally between them. So what's the distance between the center and the vertex? 2. What's the distance between the center and the focus? 3. Yep. Bless you. And then we can find B. C squared equals A squared plus B squared. Square root of 5. Yep. Okay, so let's set up our template. So it's equals 1. It's a subtraction sign for hyperbola. What's my first denominator? 4. Second denominator? 5. Now, if you're not sure, let's graph this and see which way the transverse axis goes. We're over 1, down 2. Over 4, down 2. Over 3, down 2. That lines up horizontally. So, what letter should be positive? X. So we're going to have something like this. It's always x minus h, and it's always y minus k. H is always with k. I'm sorry. H is always with x. K is always with y. So, what's x minus h here? X minus 1. And what's y minus k here? It's going to be y plus 2. That's one thing you have to be careful about if I give you an equation and I ask you to identify h and k. It's not 1 and 2. You'll get the sign wrong. It's always the number after the minus sign. The 1, and you have to think of that as a negative 2. Okay? And that's it. That's the equation of your hyperbola. So even when you shift it, it's not really too much harder if you just think of the two facts that I gave you about A and C. Okay, questions on that one? All right, and I think this will, be our last one. All right, this is very similar to the last one we did yesterday. What is going to be involved in this problem? Yep. We're going to have to complete the square. How many times? Twice. We're going to have to do it once for the x's and once for the y's, because this doesn't look anything at all like that. This is what we want. Okay, so let's see if we can do it. When you complete the square, the first thing you always do is just put the constant on the other side. Okay, you need to push that negative 11 over. The next thing I like to do is make sure my x's are next to each other and make sure my y's are next to each other. For me, visually, it's just easier. So we're going to have negative x squared minus 2x plus 4y squared minus 16y. Okay, now when you complete the square, what does the coefficient of the squared term have to be? Remember what we did yesterday? What's the coefficient of the squared term have to be? Francisco, you remember? Well, that's how we're going to find that magic number we have to add. But before I can even do that, I have to have each of these squared terms have the same coefficient. And that coefficient is 1. So from the x's, I need to factor out a negative 1. And this is where I made a mistake yesterday. So just double check that. And what would I have to factor out from the y's? A 4. And that would be minus what? 4y. Okay, now we're going to do what Francisco said. To find the number that you add to both sides to complete the square, you take the middle term, and what did you say you do with it, Francisco? Take half of it, so we get 1, and then what? Square it. And what's 1 squared? 1. Okay, let's do the same thing here. What's half of negative 4? And then square it? 4. So, whatever I did on the left, I now have to do the same thing on the right. So, what did I just add to the left? How much?
1 minus 16 17.
You're on the right track, but I didn't add 17. No, I didn't add 5. I see where you got the 5. I did a +4 and a +1, but that's not really what those numbers are, because the distributive property is involved. I added 15. Right? Here I subtracted 1, because that's a +1 times a -1. And here I had a +4 times 4. I added 16. So I really added 15 on the left, so I balanced that with 15 on the right. Okay, so now we have -1. And this should factor nicely. Two things that are the same. How does x squared plus 2x plus 1 factor? X plus 1 times, nope. X plus 1, x plus 1. Okay, and how about here? How does y squared minus 4y plus 4 factor? Times y minus 2. It's always going to have to be two that are the same. And what's it equal to? 4. Okay, we're kind of starting to get to look like a hyperbola. Something I need to fix on the left. What do I need to fix there? The what? Yeah, what about this term? Where should it be? Or we can fix something else first. What's something else that's wrong? Okay, we need to divide everything by 4, but we still have to get back to what I was just saying after we do this. So now we have negative x plus 1 squared over 4 plus y minus 2 squared over 1 equals 1. There's still something wrong with that left-hand side. The positive term should be first. If you don't do that, I think you're going to mix A and B up. Right now, that's A, that's B. And I said A was always the first denominator, but that's if you write it in standard form. So switch these two terms. Positive first, negative second. Now we're perfect, and from here, it's just like a regular problem. Okay. What's H? Think about what letter does H go with? H goes with X. -1. Okay, so a few things you got to think about. H goes with X, and it should be a minus 1. What about K? 2. A? 1. B? 2. And then C? Square root of 5. Okay, where's my center? Yep, HK, -1, 2. Where is my transverse axis? Vertical or horizontal? It's vertical. How many units away from the center are the vertices? 1 unit away. Above it and below it, or to the left and the right of it? Above and below. What's 1 unit above -1, 2? -1, 3. What's 1 unit below that? Okay, foci are square root of 5 units away. There's not a nice way to really write this. So it's going to be -1, and it's going to be 2 plus the square root of 5, 2 minus the square root of 5. Okay, and the asymptotes, think of it like this. Y minus y1 equals m times x minus x1. That's the format from like algebra 1. So it's y minus, and remember, the line goes right through the center. That's your coordinate. So it's y minus 2 equals Now your slope when it's vertical. Vertical is a over b. So what's my slope? Plus or minus a half. X minus, what's the x coordinate that this point goes through? -1. So it becomes a plus 1. If you wanted that in y equals mx plus b, you could distribute and then add 2. But there's no need to. Okay, so this kind of problem would be more of a bonus because it has the completing the square and then discussing it. But everything up to this one is regular test question stuff. Okay, so that's hyperbolas, and that'll finish up conics. For the rest of the week and the rest of the year, we'll be back in the book. Okay, so no more packets. All right, so the homework, let's see, we'll start page 411 okay, in the packet. Okay, 13 to 16 all, that's matching. 17 to 21, just the odds. Okay, 29, you can skip 31. And then 37 to 41, those are odds. And just do 53. 53 is like the last one we did. So if you get stuck on it, don't spend a ton of time worrying about it. Focus more on the stuff before that one. Okay. If anybody needs extra help, I will be here tomorrow after school, and we'll have our test on Friday.